Sometimes we have to take a phrase and translate it into an algebraic expression. And if you recall, an algebraic expression is just a grouping of numbers and variables and operations such as addition, subtraction, multiplication, or division. So let's take a look here at words that are associated with the different mathematical operations. And so you can see in our table here, with the addition, we associate the words add, plus, more, sum, total. So we'll look for those when we are translating our phrases so that we know that we have addition problems. Subtraction, we're going to look for things such as minus or subtract. Less, less than is a good one. Difference, fewer. Those all denote subtraction. For multiplication, you'll see things such as times or multiply, twice a number, or double something, or triple something, or product. And finally, for division, quotient is a word that we use for division. Divided by and divide. And I'm sure that you can think of a few more words that you've seen, but this will give us someplace to start. So let's look at each of the different phrases that we've got here below. And it says, translate each phrase to an algebraic expression. Specify what each variable represents. So our first example says twice the cost of a CD. And we're going to need a variable, so how about if we use x, and we're going to let x equal the cost of one CD. Now remember twice was in our table above, and that's a multiplication, so twice the cost of a CD. Well, let's suppose that your CD costs $10. Then twice the cost of your CD would be $20. And $20 you get by multiplying 2 times your cost of your CD, which was $10. Well, in our algebraic expression, rather than using $10 for the cost of a CD, we have using the letter X. So twice the cost of a CD is going to be the algebraic expression 2x. Okay, so now we're going to look at B, and B says 4 more than a number. So looking at our table, we know that more is associated with addition. So 4 more than a number, well, let's suppose that our number was 8. Well, 4 more than 8 would be 8 plus 4, or 12. Let's now make an algebraic expression, and rather than using 8, we're going to use a variable. And our variable, we're going to let it be n. We're going to let n be the number for letter B. And we have to do 4 more than n. And as we've already discussed, n plus 4 is our algebraic expression for 4 more than a number. 4 more than n. So now we're going to look at C. And C says 10 less than the president's age. So we know that the word less goes with subtraction. And let's just think about this for a minute. Now, let's suppose that the president is 50 years old. So what would 10 less than that be? Well, if you said 40, you're right. And so what did we do to get that 40? Well, we took 50 and we subtracted 10. So we said 50 minus 10 is 40, and so that would be 10 less than 40. Well, we want an algebraic expression, so rather than having the president's age, a number, we're going to use a variable. And I think it would be good if we used P. How about if we use P? So coming down below here, we're going to let P be the president's age. And we already said that we're going to take the president's age, which in this case, rather than being a number, it's actually going to be a variable, P, and we're going to subtract 10. 10 less than the president's age, 10 less than P would be the algebraic expression P minus 10. Okay, now we're in D. D says a number plus 10 all divided by a different number. A number plus 10 all divided by a different number. Okay, so we need 2 different numbers, which means we're going to need 2 variables this time. And we know that the word plus means addition, And we know that divided by means division. So let's use our two variables. We're going to go straight to the algebraic expression this time. And we're going to let x be the first number, and we're going to let y be the second number. So then we have to write a number plus 10. So let's take our first number, x, and we're going to add 10. Okay? And all of it needs to be divided by our second number, y. So that to me sounds like a fraction. So all of it divided by y. So there's our expression for D. Okay, let's go on to E. Okay, so for letter E, we have the product of 6 and a number. Product. So the word product, looking up at our table, that we know it goes with multiplication. Right? That's your product. Goes with multiplication. If our number was 3, the product of 6 and 3 would be 6 times 3 or 18. So we would multiply the 2, 6 and the 3. But we're going to use a variable. So we're going to let, again, we're going to let n equal our number. Now we want our product, which is 6 times n. The product of 6 and a number. Okay, and for letter F, we have the sum of the heights of two children. So sum we know means add. There's two children. We're not sure if the children have the same height, so we're going to have to use different variables for each of the heights of the children. Let's let x be the height of one child, and then we'll let y be the height of the next child. Then, since it said sum, we're going to add those two. X plus y is the sum of the height of the two children. So again, it's very important that you define your variables, especially get used to it now when the problems are simpler, and later on when we start word problems, then you'll be used to defining your variables. You'll be in a really good habit.